Hello, my name is Caleb Bradley. This is Lab 20, and during this lab, we're going to be building a analog to digital converter using the ADC0804 IC, which is right here. We have all of our outputs connected from the most significant bit to the least significant bit, so from H to A for our 7 through 0 respectively. And we have our read switch connected to switch 2, and we have our write input connected to our switch 1. So currently my power supply, you can't really see it right now, but it is actually set to 2 volts, or as close as I could get to it, because I believe it was 2.01, and I didn't want to mess around with it for much longer. And then we have our reference voltage, which is our 5 volts, which actually measures at 5.04. And then we have all of our other inputs connected to ground, and we have our, let's see, I'm just trying to make sure. We have our VCC connected here, and we have our, let's see, oh, right, well, we have our actual V input, which would be our 2 volts connected here. That connects to the 2 volt power source. So I'm going to turn it on, and I'm going to demonstrate how the conversion process works. So right now it's off because both of our read and write inputs are high. These are active low inputs, so we must make them low in order to get output out of it. What you can't see here, since I don't have the interrupt connected, you won't be able to see how it enables when I set write low, but this is an important step to actually getting our output. So when I do this, I post it, nothing happens, but it writes a bit to the value. It writes the bits to a value that we have come up with. So when I press read, we're going to get an output now. And here we are. So this is the digital equivalent to the decimal number 102. So I can do it again. If I leave write high and then I go back to high with read, everything becomes disabled. But then without changing write, I'll demonstrate that the value stays the same. So reading again, I get the value for 102, and that concludes Lab 20.